order to solve certain types of integrals, it is necessary to use identities, which will allow us to express a trigonometric function into a combination of sines and cosines. They consist in simplifying an unfamiliar trigonometric function into something we already know how to integrate. In this example, a constant divided by cosine is directly related with the function of secant. We rewrite it using secant and keeping the 3. Then we identify the u and its derivative in order to balance the integral. And outside we need to write the reciprocal of the value we use to balance. Finally, we use the catalog to solve the integral. In this example, we can relate tangent and sine using the function of tangent. First, we rewrite tangent using the identity of sine over cosine. Then we cancel sine. Now we are able to solve the integral using cosine. We rewrite it including the 3x. Then we identify the u and its derivative in order to balance the integral. And outside we need to write the reciprocal of the value we use to balance. We finally can solve the integral using the catalog.
The first step in this problem is to get our u and our du. Since we are using substitution, our u would be the one that has the exponent, in this case sine 3x, and our derivative would be 3 cosine 3x. As we can see, in our original function, we already have cosine 3x, which means that we are only left to multiply in the inside by 3, and as well divide on the outside by 3. Then, we need to treat this function as a normal integral, which means that we only need to add 1 to the exponent and as well divide everything by this number. In this case, we are left with the final answer as sine to the 4th power 3x over 12. Oh, and don't forget to add a constant. It is important to keep in mind that any other method will not work for solving this problem. Why? Because there is not a specific identity in the catalog that can help us integrate directly a function such as sine to the 3rd power cosine.
When solving a trigonometric function raised to the 4th power, it is necessary to follow a series of steps in order to get to the final answer. First of all, have in mind you'll be using double angle identities. We will start by rewriting our function so that we can solve it with the given identities. Rewrite the function as a squared function raised to the 2nd power. Identify the respective trigonometric function and rewrite it as its equivalent identity. In this case, we will use cosine squared. FOIL. You must expand the function so that you can continue solving it. Notice once you've expanded it, you have a term raised to the 2nd power. Replace its equivalent double angle identity and expand. Add of like terms. In this case, we will sum our two constants, which are 1/8 and 1/4. Finally, we will integrate each term separately, either by the traditional method or by using the catalog. Don't forget to add up the letter C.
Hi, now we're going to see integration of odd powers to the 5th. The odd powers are different to the even powers because we need to use the Pythagorean identities. If we use the double angle identities, in some point the integration will stop without getting an answer, a specific answer, the one we need. So it's try and error, but with these rules you can get it faster. Now let's have a next small example. In this example, we choose sin to the 5th. The first step, we need to separate it into sin squared to the square times sin. That gives us sin to the 5th. In the second step, you need to find the Pythagorean identities and find one that is sine to the square. You substitute and then you replace it. So you start to develop the equation with the square, with the perfect square, and then you have a big equation that you need to multiply. After we do the full equation that is multiply the factors between them, we have a big equation that we need to separate into 3 different integrals. These 3, we will have to resolve it in different ways. The first one, we can solve it directly from the catalog. The integral of cos is sine. In the second one, you use the substitution. You know that the derivative of sin is cos. We eliminate, we add 1 to the sin square and divide it by it. And in the last integral, we need to do exactly the same by substitution. We add 1 to the power and divide it by it. And you add a c at the end.
In order to solve this problem, first we will divide the original integral into 2, one with an even power and one with no power. And instead of using double angle, which would prove to be incorrect, we will use Pythagorean identities, in this case, the one for cosine squared. Then we will use FOIL, multiplying this by this and this by this, and finally separate it into 2 integrals, so we can get the u and the u of each one. Now, these 6's will be multiplying inside, so they will be dividing outside. And in here, we can use the identity found in the catalog to get the sin 6x over 6. Meanwhile, on the other integral, we cancel cosine, and are left with the sin squared, which we will integrate, so we end up with sin to the 3rd power over 3, which will be multiplying by the 1/6 outside. Now, the only thing missing is multiplying the fractions to get the answer, and of course, don't forget the constant.